In this video, we want to look at pH analysis. And when we talk about pH analysis, we're referring to the percentage of acidic content, what we know as pH, and the percentage of alkaline content, what we call pOH. So when we talk about pH, we're referring to the percentage of hydrogen ion concentration in a solution or substance. Now, what it means is that it measures the degree of acidity and alkalinity of a substance or solution. So if, for example, we say this is a pH meter, it ranges from 1, 2, 3, 4, 5, 6, 7, down to 14. From 0 to 6 measures the acidity. So in this place, if you're moving this way, you are increasing in acidity. 7 is neutrality. And if you're moving from 8 towards this place, you are also increasing in alkalinity. So this is acidic side. This is alkaline side. So 14, alkaline side. So it means this is more acidic than this, more acidic than this. As it's moving towards 7, it is slowing down. So when you get to 7, it is neutral. As you are here, this is more alkaline than this. This is more alkaline than this. So as you are moving towards this, you are increasing in alkalinity. That is why we say that pH is mathematically given as negative logarithm of concentration of hydrogen ion, or we say that it is the log of the inverse of hydrogen ion. And likewise, pOH is the negative log of concentration of hydroxy ion, or negative log or inverse of the concentration of hydroxy ion. Before we go to calculations, let's look at one or two salt analysis. If we have a strong acid against a strong base, you notice that this will be stronger than this, and it means that this and this are the same, strong and strong. It means that both of them will neutralize each other, so it will be neutral, and because of that, our pH will be 7, so neutral. But if we have a strong acid against a weak base, you notice this is stronger than this, and because of that, the pH of the solution would tilt towards the stronger person, and because of that, the solution will be acidic. And since it's acidic, it means that the pH will be less than 7. And if we have a weak acid, for example, against a strong base, this will overpower this, and because of that, it will be alkaline, and then the pH will be greater than 7. But if we have a weak acid against a weak base, against a weak base, we're going to have a neutral as well, and then because of that, pH will be equal to 7, neutral. And we also need to note that for a distilled water or a pure water, the ionic product of a distilled water is equal to 1.0 times 10 raised to power minus 14. What this means is that pH plus pOH is equal to 14. Because of that, pH is 7, pOH is 7 for a pure water. It means that the concentration of hydrogen ion and the concentration of hydroxy ion, they are equal, and both are 7 plus 7, that gives us 14. Now this question says, calculate the pOH and pH of 0.125 mole of NaOH, that's sodium hydroxide. Now, if we look at the self-ionization of this sodium hydroxide, we'll have something like this, splitting into Na positive plus OH negative. What this statement means is that the concentration of this sodium, if this hydroxyl ion is what is 0.125 molar. So because of that, remember we said that POH is given as negative log of OH minus hydroxy ion concentration. So if we say that POH is equal to negative log of 0.125. So having had this, now we can have that this is equal to negative log 0.125 will give us negative 0.903, and negative gives us positive. So what it means is that POH is equal to 0.903. If this is 0. This, remember that pH plus POH is equal to 14. What it means is that pH plus this is already 0.903. It gives us 14. If we now make pH subject of the formula, it will be that pH will be equal to 14 minus this value, which is minus 0.903. And if we press that, we'll get 13.097. That's the pH. This question says calculate the pH of 0.10 molar of acetic acid, 13% ionized. Now, since we are looking at acetic acid, it means it's an acid, and an acid we're looking at pH, and we know that pH is equal to negative log of hydrogen ion concentration. So because of that, we can say pH is equal to negative log of, remember it is 13% ionized, and the molar is 0.1. So we say 0.1 times 13%. 13% is simply 13 over 100. So which is 0.13. So we now have that pH is equal to negative log of 0.13 times 0.1 will give us 0.013. So we will now have negative log of this, which will give us 1.89. Likewise, the second one says we should calculate the pH of 0.1 molar of HNO3. Now when we look at HNO3 is a base, so because of that we're looking at, we say pH is equal to, is an acid. HNO3 is an acid, so we're looking at pH is equal to negative log of hydrogen ion. So that's what we're looking at. So simply we say pH is equal to negative log of 0.10. And when we press that, we're going to get 1.